All right, let's go ahead and get started. Welcome. It's good to see such a nice full classroom today. My name is Joe Zambrino, and for the next 15 weeks or thereabouts, I will be your guide through the exciting world of EE285, problem-solving methods and tools for electrical engineering. We'll start today off kind of the most formulaic, maybe boring way possible by looking at what this class is about and reading off the catalog description. Now, this is written in that registrar catalog kind of jargon, but we can really focus on just the first sentence. So this class is integration of field-specific computational tools for practically solving electrical engineering problems. You are all future electrical engineers, and using computers to solve problems in your field is going to be critical. So critical that we start you off early in one of the very first courses you take as a EE student here at Iowa State University is how to use computers effectively. If you read the rest of that, how to write programs and interface with computers in order to solve electrical engineering problems. We are not going to become necessarily masters by the end of this semester. This is your first exposure to the topic, but certainly between hopefully now and the end of this semester, you'll become so much more fluent with how to use computers and how to write programs to solve electrical engineering problems. Why does this course exist? It is our programming pathway for EE students. Students who are maybe picking a more computing-focused major like computer engineering or software engineering, cybersecurity engineering, take a more traditional computer science sequence. Here at Iowa State, that's ComSci 227 and 228, an introduction to Java type course or a data structure course. And there was a time many years ago where as a EE student, you would have also effectively taken a version of those two courses. In our department, we really recognize that as EE students, the backgrounds are different, the needs are also a little bit different. So through this course, as well as followed on required courses in your major, we are attempting to provide a version of that type of background in programming that is more relevant, more purposeful for electrical engineering students. And the broader goal is to prepare you for those follow-on courses. This is not the last programming course you will take here as an electrical engineering student. It's the most important one, hopefully the most enjoyable one. But after this, you'll get a chance to take your Signals and Systems course that does involve programming. Certainly the CPRE 288 Embedded Systems course is a very heavy programming course. And just beyond that, beyond just your education, beyond just your degree program here, the goal of this course is really just broaden your engineering knowledge. Engineering and computing are tightly related in all engineering disciplines, and electrical engineering is no different. So beyond your time here at Iowa State, my hope, our goal, the whole plan is to prepare you for your future career in electrical engineering, which if it will not involve programming directly, although many more of you will be programmers when you graduate than you may realize today, if it does not even necessarily involve programming directly, will almost certainly involve working with other programmers and understanding what other programmers are doing. By the way, it's a full classroom, it's the first day, everyone's very kind of like focused, which is good, but also a little like, I don't know, scared looking from my perspective. Just feel free to like just interrupt if you have a question. You can raise your hand, or if you have a thought, just we can kind of collaborate here. It doesn't need to be me talking to you the entire time. We can do that too, but we don't need it to be that way for this semester here. So this class is a programming course. If that fact scares, intimidates, concerns you, that's okay. You're in the right room, you're in the right place. Well, if you're in the wrong room, just sneak out quietly and that's okay. But for the most part, you're all in the right room, in the right place. We're here to learn. That is the point of this course. That's always my philosophy as an instructor. I love this course. I enjoy programming. I like the material in general. I like working with students. I'm here for you to be successful. We'll circle back to that later today and later this week as well. But when I talk about programming, we have to be a bit more precise with what we're referring to, right? That's kind of a textbook definition or like the wiki definition of what programming is. It's the process of writing, testing, and debugging and maintaining the source code of computer programs. We don't do a lot of maintaining in this course, only because it's kind of its own separate thing that is important, but maybe learned later in your career. Writing, testing, and debugging is an important aspect of what we are going to be learning here. When we refer to the type or the nature of the source code we are working on, that's what we are referring to when we refer to a specific choice of a programming language, the Java programming language or the C++ programming language or C programming language. And the programming language itself, and here's a couple terms maybe you've heard or maybe not heard, is defined by having a unique syntax, first off. What are the very precisely defined rules about what sequences of text are valid for a program in a given programming language? That is important. Equally important, but maybe a little bit harder to eventually understand, are the semantics of a programming language as well. That's just a slightly fancy word for a given syntax, what does that text ultimately mean to the computer that it is going to be executing on? We have our own intention as a human, as the programmer, for what we mean when we write something in our code. There's the actual semantics of the language, which is for a given thing that we actually typed, what did the computer interpret it to mean? And when we talk about the process of being a programmer as writing, testing, and debugging, the writing part, I think you will find eventually, maybe not right away, because it is certainly challenging if you haven't done it before. The writing part tends to be less time intensive and challenging than the testing and the debugging phases. Because a fundamental consideration as a programmer is, I have my idea, I have my goal in mind of what I want my program to do. I have my own semantics in mind. I want the program to do this. I write some syntax. And assuming, to start with, that my syntax is valid and it's acceptable to the language, to the program that is interpreting my language that I'm entering here. Still, the main challenge is I intended one thing, the actual semantics of the language imply that something else should be done instead, and I have a bug. My code doesn't do what I hope my code was supposed to do. So when I talk about the various phases of programming, writing the syntax, yeah, it's challenging at first, but testing, confirming it does what I think it should be doing, and then when that's not the case, when it's actually wrong, debugging, determining why it is not doing what it should be doing, is where you'll be spending your time, by and large this semester. We don't write especially lengthy programs. That's not something that's especially relevant to us. We do spend a lot of time debugging relatively short programs. Part of that process, as we'll learn a little bit later, is that we write our code in some text format in a file. That so-called source code in that file is going to then be translated by the computer we're executing it on to a format that's more directly understandable by the underlying hardware in that particular computer. And here I'm referring to your laptop or your phone or a remotely accessible computer that you're executing the code on. We can back up a little bit before we get into more detail on that. What is a computer? I've used the term about 15 times already this morning. Any thoughts? What is a computer?
A machine that processes information.
Sounds good to me. Oftentimes I get a definition at a first guess is a computer is something that computes, which is actually correct, it's just kind of circular in terms of a definition, right? So oftentimes the definition of what is a computer goes to the definition of what does it mean to compute something. And it has to do with processing, although that's also kind of a synonymous word, processing and computing. It has to do with both calculating something and making decisions based on those calculations. So I have to do some sort of usually arithmetic at the end of the day of some way, shape, or form. I have to usually grab some input from some user in some way, shape, or form. And my program in my computer has to make some decision in some way, shape, or form here. And that's what I meant by the characteristics, qualities that a computer could have. This is just kind of a brief metaphysical question to start our first day of the semester. Are cognizant animals computers?
Yes.
Are we computers? Are you a computer?
Oh, yeah.
Okay. It's meant to be a more open-ended question, but yeah, yes or no also works for that as well. Yeah, probably, I think I would say. The actual human program that we execute, and we all do it differently, there isn't like one human program, right? The actual human program that we execute is sometimes, I think, pretty explicit in terms of what we're being asked to do at any given point in time. But other times it's not. And let me just say that this is a very simplified way of thinking about things, but it's sufficient for our purposes here, certainly today. More deeply, this understanding of, what does it mean to learn something? What is intelligence? How does it relate to what computers can do versus what biological organisms can do? That's a deep and that's a kind of constantly evolving, research area. So there isn't one answer for the human program and what does it mean to be something that processes or computing. But if you were given this task of what is the date 1 week from today, you're all going to do it differently. There isn't exactly one way to do it, but in a sense, you can start to see the analogy between what you as a human would have to do to answer that question and effectively what a computer has to do to also kind of answer that question. If this seems too basic, that's okay. Don't worry, this class will get there pretty quickly. What is the date 1 week from today? Well, this is maybe my version of my thought process. Well, today is the 22nd. The computer analogy is load some value from memory. So if I add 7 days to that, I get 22 plus 7 equals 29. So it's doing the processing, the arithmetic here, calculation. And since the result isn't greater than 30, that's a decision being made based on the result, because it's not February. We don't have to worry about being greater than 30. I can raise my hand and let the teacher know the answer is the 29th. That's like outputting the result. Logical, consistent, computer-like. I only realize right now there's a slight problem with it. What's the problem with it? Yeah, okay. So my syntax is good. The math is correct. The human program did exactly what I told it to do based on the input. You'll find that a lot in your programs. The computer is never lying to you. It is doing exactly what you told it to do. The challenge is that kind of cognitive mismatch between what we think we're inputting and what we actually need it to input. Okay, we'll call that a typo and an intentional typo, and any future typos you see on these slides are entirely intentional and not due to my not updating the slide. But that's one more explicit version of the human program. Logical steps, do a little bit of arithmetic, make some small decision based on the result. We're constantly doing that all throughout the day. Some days more than others. Other times that connection, or really that allegory between sort of the human program and the computer program, is not nearly as clear. I don't want your answers to this particular question, but what does the following picture in a Rorschach type blot, what does it look like to you? Everyone's internal processes, I think, are fundamentally different for how we process that, and we may actually have a little difficult time putting it to words as well. Like, what is the actual calculations and or decision-making processes that we follow? Now, again, as an evolving kind of area of artificial intelligence and how we can use computers to actually infer things, one can today write a program that provides some meaning for that as well. So that disconnect is even less than what it maybe used to be. Long story short, with this concept, yeah, sure, we can think of cognizant animals, we can think of ourselves as being computers. The process that we follow is very similar oftentimes. The difference is oftentimes that we have to make sure we understand how the computer is interpreting what our instructions are and what we think we're providing as input to the computer. Because ultimately, underneath that syntax, underneath the text input we provide as programs to our computer, there's a lot going on. And this is something, as electrical engineers, you will eventually learn quite a bit more of it. And this is actually just kind of the software side of the abstraction. There's also the hardware side of the abstraction. You'll learn quite a bit more, where we worry about the logic gates and the transistors and the semiconductors and the underlying physics. How deep you go either on the software side or on the hardware side really depends on your interest areas. But as electrical engineers, you'll get pretty far on both ends just through your courses that are required in the degree program. But underneath the relatively high level abstraction of text input to a computer, there's a lot of layers of translation going on. This is just on the software side. Ultimately, our text input we provide to the computer is going to get translated. It is going to get translated depending on what level of abstraction is. Here's a little bit of MATLAB code, to some sort of potentially intermediate representation. Some intermediate format. It could be something closer to like a C-like code that we'd be learning this semester. some sort of intermediate translation happens, one or multiple layers of that. Often then times before it's actually going to be executed, it has to get translated to more native looking instructions that the computer, the CPU itself, can actually understand directly. That's referred to as assembly programming. You may or may not get some exposure to assembly programming. It really depends on the nature of interest you have. It's not a requirement for EEs to learn assembly programming, but there's plenty of opportunities if you're interested. And if you were to take a course like CPRE 381, which is not a requirement for you, but it's an elective that students do take, you learn a lot about this layer of the process. How do I go from my higher level, relatively higher level language down to ultimately the ones and zeros that my CPU, be an Intel Core i7 CPU, understands and actually knows what to do with. As an electrical engineer, you'll then learn what also happens after the fact here. Not at this layer of detail. This chip may have 4 billion transistors on it. We start small and work our way up to that, right? But the individual processing elements, how they're composed of gates, what does that mean from a semiconductor and a VLSI perspective? There it depends, as I mentioned, more on your interest levels, your focus areas. But you will learn more about how we eventually get there to here. From our perspective for this class, being aware that this happens is probably sufficient. That there's a series of software steps that go from what I would like the computer to do next, what I would like my program to do, refer to it as the specification, for want of a better word, for my program, how I go from that textual input into something that this software can then take and ultimately give me the end result that I am hoping for. So why this course? I've already touched upon this, but I don't think I can belabor the point. You don't know me, but trust me when I tell you that programming is critical for electrical engineers. Our top employers of EE grads, assuming you would like a job in the industry when you graduate, I know this is a lot, this is day one, but assuming you do eventually want a job, they all expect their hires to be proficient with problem solving using computers, including both software development and interfacing with other developers. There was a time, relatively long ago now in terms of decades, not years anymore, where the thought was if you didn't want to do programming, you can be a EE and you wouldn't have to really worry about it. That is no longer the case. Our employers, our top employers, the kind of jobs you will generally want may not be hiring you as a programmer. That may not certainly be your title. You'll have all sorts of different other titles, certainly in your first EE job that you will get. They will expect you to be aware of this topic, fluent in this topic, have an appreciation for this topic. Whether it's your passion or not is a different thing, but we can't be ignorant of it. And so even if your career goals do not involve programming, it kind of goes a little bit bimodal. I would say after a class like this, in my experience, after having taken it, you'll learn a lot and you'll discover about yourself, okay, I know programming now well enough. I love it and I want to do more of it. Or I know programming now well enough, I don't want to do it very much ever again. You'll learn that one way or the other. But even if you don't decide that programming is part of your future career goals, takeaways from this course are still very helpful for your career development as an engineer. First point I think is critical for an engineering problem-solving process. Computing and programming is part of that process. So it is a vehicle for our creativity as engineers, and also it's a very clear abstraction of the engineering problem-solving process. All we do in this class is engineering problem-solving. It may not involve calculus. Some may think that's a good thing. Others, wish it would have more calculus. But it is very much engineering problem-solving from day one here. Step 2, learning through failure over and over again. You may not believe me, but this course is about not trial and error necessarily, but writing code that doesn't work and then determining what to do next. And the successful students in this course, and on day one, there's no reason to believe you cannot be 100% successful in this course, are those who, when they face an error, they say, okay, what do I do next? Let's keep trying. And it's not just one error. It's 2 errors, 3 errors, 4 errors, 5 errors. The fun programs, it's over and over again. And that connection to point 3 here, critical aspect of programming is debugging. Debugging referring to my code is wrong. I've written it. I feel like I've written every line of code I need to write for this program, this assignment, this class, this project. It doesn't work. Why does it not work? Asking those questions and working through the debugging process. I don't know how well I teach debugging as a mindset. That's something maybe I need to get better at. My job, as I see it, is I provide you with opportunities to strengthen your own skill set with debugging. And I kind of hope you just learn over time and through just repetition. But it's pretty critical. Computing and programming debugging tends to be a very specific type of debugging, but that mindset I think that you will strengthen and develop over the course of the semester will hopefully help you in other classes and other life goals as well, which is, doesn't work, I'm not going to give up. I'm going to try to think logically and gain more information for how I can get my code to actually work. And that's connected to the final point here. Overall, coding will help you become more logical, precise, and resourceful. I give you the specification for what I want your programs to do each week in this course. I do not tell you how to do it. They're not made up out of whole cloth. I give you a program because I believe based on what you've been learning in the recent days and weeks, you should be able to determine how to write the program. You are going to have to write code that's logical. I need to break down the problem. I need to think through it. I need to be precise. When we speak, we can be inelegant and imprecise and still mostly understand each other. Certainly, I use malaprops and say all sorts of imprecise things during the semester. When I'm interfacing with the computer, I need to be precise. It is going to do exactly what I tell it to do, no more, no less. And being resourceful. This goes back to debugging. My code does not work. It is broken. I am sad. Where do I go next? Sometimes it's just internally. Introspection, reviewing, reading, thinking. Other times it's externally. My code's not working. What do I not know that I thought I knew? What other resources do I need to look at to be able to answer those questions? And I already mentioned this. You don't have to love programming. By the end of the semester, I think you'll respect it. Sure. Sure, and as we talk about the problem, like the engineering problem-solving process, there's going to be various stages of it that we're going to learn throughout this semester. When I say thinking logical, it's really about having that deep appreciation that you will gain for the interface between us as programmers and the resulting machine that our code is going to be running on. It doesn't necessarily refer to logic both in like the formal logic or in like the digital logic sense, although we'll learn a little bit of that as well. It's really about understanding, okay, I know what I want the program to do, like calculate what the date is 1 week from today. What are those individual steps that that's going to require? And it's a little bit tricky to lay out all those steps right now because the way this course, and really any introductory programming course is structured, there's a lot of potential steps that that task can take. And we don't learn them all at once. So we learn a very small recipe book of steps that we can take in our programs. And then we keep adding to that over time. So the logical steps that we have to take when writing our programs and debugging our programs is going to continue to expand. And you'll see that. The programs we start with are very basic to begin the semester. They are going to grow in complexity as we learn new things. The logical process we have to follow also then changes only by necessity. Now that we can do more things, we can think about our programs a little bit differently. My hope is at the end of the semester, you look back at like your week 2 programs and you kind of laugh. And you say, oh, this was so easy. Why did I think this was a difficult program? At the time, at the moment, it's supposed to have some reasonable level of challenge. But as we learn more and more skills and can do more things and break down the problems in more advanced ways, you may even find things like, well, this program took me 50 lines of code in 2 hours in week 2. Let's say week 3. Week 2 is a little early for that. And it's actually just 3 lines of code and a relatively straightforward approach by the end of the semester. So all about the C programming language, which is the primary focus and our choice of programming language in this course. Let's start with a quick show of hands. Who here has programmed before? Half and half, typical. Who here has programmed in C before? Small handful, more than I usually see. You can put your hands down, thank you. We're mostly on the same page with regards to this. C is a well-weathered, well-understood programming language, primarily used today in what I would refer to as system software, software for which, if we want to write a compiler, we would oftentimes use C, or major components of an operating system. Also for general purpose applications as well. I think if I were to, start a general purpose application for an arbitrary task today, it really depend on what the domain would be, whether or not I would choose C programming or not. C is a very old programming language. I may not look it, but C is in fact older than I am. Why am I making you use it? There's valid reasons for it. First off, this could be thought of as a negative, but from my perspective, it's a positive. C abstracts relatively little from the underlying architecture. There will be times this semester, but not right away, so we don't have to stress about it. But there will be times this semester we have to have this mental image back in mind to be able to debug our C programs. Not right away, but it will happen this semester. C does not abstract much from what's happening underneath the hood. It does require you to understand how computer systems work. That is a primary learning outcome of this class. For that reason, harder, easier is kind of relative, and it's really just an opinion, not a fact. It is arguable that it's a higher learning curve to become proficient in C than to become proficient in some other so-called higher level programming languages. I think that's neither good nor bad. That is a design decision as an electrical and computer engineering department that we have made. The C programming skill set, due to its kind of foundational history, it's the progenitor of all these other programming languages directly or indirectly, the skill set is very upwardly mobile. What I mean by that is you can get proficient in C by the end of this semester. There's always more to learn, so it's not like you're done learning, but you can get proficient in C by the end of this semester. The skill set is upwardly mobile, that when someone says, now it's time to learn Java or C# or Python or Go or something like that, you'll be able to do it. The reverse isn't always true, but it's upwardly mobile. We learn the lower level, less abstract programming language first. When you have a requirement for an internship or some other project or a course to use some other programming language, as an engineer you say, okay, give me the reference manuals, probably online. Give me the reference resource for this particular language. They're all going to look, at least for this general class of programming languages, they're all going to look sufficiently C-ish that you're going to do just fine. You'll have to learn the difference in the syntax and the semantics of the language. You're going to be able to handle it. Similarly, and it's kind of related, the really high-level languages that do a lot under the hood to kind of hide the underlying implementation details, like a MATLAB, and as a double E, you'll get plenty of MATLAB experience if you haven't already, like a Python, like a Golang. They'll astound you, I think, in a good way in terms of, okay, I learned a lot of kind of the nitty-gritty computer systems details in EE285. I've become proficient in C. Now I have a task I have to implement in Python, and this is easy. There's still bugs to fix and things like that, but you're going to be happy with how productive if you have a project that requires that you use Python with the foundations and the fundamentals we've learned in C. Ultimately, that's what matters. Understanding the fundamentals of programming and computer systems, C is sufficient for covering those. What is going to be quote unquote hot in software development by the time you graduate is going to be changed from today anyway. There's no point, I think, as a department in us chasing the latest and greatest. We go with C. We reflect on that design decision as a department periodically. Think it's sufficient to be able to express your creativity, to learn the engineering problem-solving process, and to learn how to code effectively. Sure.
You mentioned about the slightly higher learning curve. Is that the syntax or the troubleshooting with like what's under the hood?
Both. Yep. So I think it's a good thing. So we learned the kind of dustiest, oldest language that does keep evolving, but relatively modestly. Unlike C++, which some universities would have C++ as your first programming language, every 2 years effectively, C++ undergoes major revisions. And there you're really about learning, picking up new syntax. The syntax we understand, it's low level. It does not hold your hand by and large. We use some tools as well as things like TAs and my expertise and each other as peers to help each other kind of learn as we go. But the language itself is relatively closer to doing assembly language than it is something like Python at the end of the day. You will respect it. I think you'll learn to love it by the end of the semester. Yeah, sure.
You'll say that it's pretty old.
Well, 50 is pretty old for a programming language, yes.
Yep. I don't know what basic used to be a programming language or something.
Sure, still is.
Does it obviously like C?
Well, I guess partially because I've been programming like, effectively my whole life now, right? And have done so many different programming languages, and I like to tinker anyway. So I'm always picking up new skill sets there. To me, there are a couple subcategories of programming languages that feel different than C. You may not be familiar. Erlang, just to give an example. Highly functional Lisp. Those are a little bit different beast. You would learn those in advanced classes in the computer science department, if at all, really, here in a university setting. For this general class of languages, in which I could have put basic, whether Microsoft style of basic or old school kind of basic, it's very similar in terms of the problem-solving process. The underlying features of the language and the syntax are always a little different between them. But if you learn C well, or frankly, if you learned another language well, you should be able to internally do that mental translation between, okay, here, just to give an example, since if you're familiar with it enough, here's how I did a for loop in BASIC. It is different in C, but it's just syntax. It's not fundamentally different. You're doing something very similar. It's the problem-solving process. Why do I need a loop in the first place is the important part. The syntax, you get it wrong, I'll help you fix it. Eventually, you won't need my help to fix it, and you'll be able to write for loops in C. Also in this course, which is not ComSci 101, is not Introduction to Java Programming, it is EE285, we find it very critical that as electrical engineers, you become just more fluent in using computers. Some of you may feel that that's a silly thing to say. Of course I'm fluent in using computers. But really understanding how to be effectively, I would call it like a power user of your computer, separately, but also in addition to learning how to program, you will find, not necessarily in this course, but later on in projects and in internships and job and life, that those two things are actually quite related, oftentimes. And I can't tell you how often it's the case that as I'm working with graduate students doing R&D type projects here at Iowa State, understanding how to get my system up and running the way I need it to is actually harder, more important than the actual code that we run. Some of the most incredible software you can imagine today, generative AI that can take a very simple text string and generate this incredible lifelike looking photorealistic image from it, in terms of lines of code, relatively modest. Some of the demos that are very effective are 20 and 30 lines of Python code. Underneath the hood, the underlying configured system that allows you to only have to write those 20 to 30 lines of code is actually quite complicated. There's different terms for what that means. What I just refer to is I'm referring to just the systems interface. It's understanding how to be a more powerful, adept user of your underlying computer, working with the operating system, versus just be someone who runs apps in your underlying operating system. We will be doing that all semester, and if you haven't had exposure to that, that's okay. It should be new for a relatively high percentage of people in this class. It is a learning outcome of this class. You will find that you're ultimately limited by how resourceful you are. How do I do X with Y is going to be a very common kind of Google search we'll do this semester, or finding manual pages or other tutorials and resources. Because you will find that once you gain that skill set, you can think of it as like a DevOps, an administrative skill set, just a programming support, computer systems interface skill set. You'll just find that you just become a very powerful computer user. It'll seem almost like magic to your fellow students or future colleagues who don't necessarily have that skill set. Just to give a random example here, if I want to replace all instances of Joseph with Joe in the text files, but only if it has Zambrino in the same line. So my name is Joseph, I go by Joe, it doesn't matter, just call me Joe. Professor Zambrino, Sensei is fine, whatever you want to call me is fine. Let's say I wanted to go through all my text files of every file we've ever written and replace that. I can write a program to do that. That program is a bit beyond us right now, and that's okay. Just the thought process would be, well, I guess I'll write a script that traverses all my directories and then like develop a program that searches line by line for Joseph, replacing blah, 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 blah. A fairly complicated program. There's nothing wrong with that program. If I gave you that program as a task, later on in the semester, you'd be able to do it. But it's a decent program. It's a lot of lines of code. Eventually, we gain a better, deeper appreciation. For us, it's really the Linux that we're using, operating system, but it could be Windows, Mac. It's not really specific to Linux, what we're learning. We recognize that people who helped develop these systems, many of which were kind of co-developed in concert with the C programming language, built so many powerful utilities. Think of them as kind of magical incantations that allow us to do so much with singular commands and or chained series of commands. We will learn that this semester. There isn't necessarily like, here's one tutorial for how to become an adept Linux user. What we provide is a relatively safe, clean environment to learn how to do that, an environment where you can't really break anything effectively. It is in addition to programming, but it's directly related, because ultimately as an engineer, your job is to get a task done with a particular specification. Your job was, okay, this is synthetic, but your job was to do that task. Several days, a little bit of time to understand it, but once you understand it, several seconds, right, to be able to do that kind of task. So starting from day one in the very first week of lab, the very first assignment, it won't be all that. This is not a class on bash, shell scripting, and things like that. That would be a fun class. That's not what this class ultimately is. But starting on day one, we'll be doing a little bit of that, in addition to understanding what would the program look like for that. And you don't have to currently today understand what that command is doing. You can kind of squint at it and maybe kind of guess and kind of get a feel for maybe sort of what it's doing. But it's okay for now. You'll get there. I already kind of asked this. I asked it slightly differently. I asked it in terms of who has already programmed before, and that was a good chunk of the class. I also asked who has already done C programming before. That was about a third of the class. I like to bring up this chart before we kind of start to get into the real nitty-gritty details of the semester. And I bring up this quad chart of your own kind of self-perception of your background in programming. This can apply to a lot of things, but let's apply it to the concept of what we think we know about programming. In terms of, on the x-axis, your self-perception of how much you know. You can put yourself in one of these four, or at least one of these two quads to begin with. Am I a real novice? Am I coming in here not knowing what I'm doing? Or do I feel like I know what I'm doing already? Likewise, although you don't necessarily have the mechanism to assess this yet, that's kind of my job to assess this, what is your actual expertise in programming? What is your actual background, experience, skill set in programming? You are going to find yourself in one of those four charts here. I don't know if I have it animated here. Sure. So, okay, if it turns out you believe that you're a really good programmer and you actually are already a really experienced and good programmer, good. This class will be fine. There'll still be some challenge. I think you'll still find some value in it. Pick up an extra hobby this semester. You'll be just fine. This class will not hurt you in any way. You'll still find things to learn. I can promise you that. We can go down some fun paths together. So if you're in that quadrant, fine. You're going to do just fine here. Similarly, although I guess not as common would be, I don't think I know how to program at all. I perceive myself to have low expertise, but actually I'm really good at programming. That's not that common, I guess, right? So low self-esteem, I don't know why you would find yourself in that quadrant there. You'll also be just fine in this class. You'll be stressed out about it until about halfway through the semester you realize you're doing just fine. Great, keep up the good work. Very importantly, you're in this quadrant. This class is for you. You don't know how to program. You're uncertain of your skill set, how well you stack up to your peers. This could be for many of you, it's your first day of classes at Iowa State University, transferring in or finding your way into electrical engineering. This class is for you. This class is created for you, structured for you. My job is for you to be successful in this class. And I mean that. This is not a weed out class. I'm not here to filter you. I'm not here to make you want to switch out of electrical engineering into some other safer, easier major. With all the caveats from before that you don't have to necessarily love programming, but effectively respect it by the end of the semester, this class is for you. You are fine. The only category of student, and there's always one or two in a given semester in a class of this size, would be those who fall into that fourth quadrant there, which is you think you really know what you're doing, maybe you don't, and so you don't take the class seriously from kind of day one. because I will need you to do that. So you don't know which of those 4 quadrants you're in necessarily. That's what makes it kind of challenging to kind of self-organize and structure a class in this way, shape, and form. If everybody treats themselves as being here, you're going to do just fine this semester. Just be aware of a little bit of that programmer's hubris. Yeah, I took a programming course. I know what I'm doing. I had an internship. You might be in that upper right quadrant. Have a little bit of humility to say that, okay, this is W285, which I haven't taken before, I think by and large. I need to put in a good faith effort because as we learn more and more of C, syntax, and semantics, there's challenge in this course. This is not an easy course. It's a course you can very much be successful in. I have a little fun with some of the programs in this course. You're going to get some challenge. Another kind of, you can think of this as inspirational or kind of analogous kind of way of thinking about it. This trend is just over time and something good, something you want to get better at, some metric you want to improve. From the perspective of this course, this is relevant for my ability as a programmer, perhaps is our y-axis on this particular chart. And the quote I like is, a little bit of slope makes up for a lot of y-intercept. You may be stressed out today that you feel you are here, and everybody else, when you talk to them after class, you feel like they might be here. And of course, that might be the case, right? We all come from different backgrounds with different experience and exposure to programming, and maybe just different initial innate ability. That's fine. A little bit of that slope can really make up for that additional amount of y-intercept. So if you feel you're already behind on day 1, first off, like I said, you are not. But if you have that perception and you haven't had as much experience as other students in the class, that's how you make it up. This is an effort discipline. Engineering, electrical engineering, programming is not a genius discipline, despite what anyone would want to tell you. It is based on our ability to try, to be resourceful, to not give up when things are not necessarily going our way and we're struggling. And that's who the successful programmers, that's certainly what the successful graduates of our program are reflective of. Not of genius, but of whatever you want to call it. Steadfastness, hard work. Effort is good, not giving up. Let's talk syllabus stuff. We got time to get through some of it today, but then we'll wind up picking this up on Wednesday. I want to get to some of this. If we go 30 seconds late, we'll be fine. This course is organized as 12 weekly topics. Our Mondays will be big picture conceptual overviews. Wednesdays, we will be having a weekly quiz. They are primarily attendance quizzes, but like it's physical attendance as well as mental attendance, quizzes is what they basically are. Fridays, I think I'll try to be more hands-on kind of coding practice together in class. That's my attempt to structure it as best I can. I'll keep to that basic schedule. Each of those 12 topics is going to have a corresponding reading assignment in our zyBooks platform. Please check that out today, and you do have to purchase it if you have not done so already, as well as a coding practice assignment that I'll talk a little bit more about on Wednesday, because I don't think I'll be able to get to it today. The idea of the reading assignment is that it is our textbook. It is an online platform because the platform is there and it kind of works for us. Forces you to read it, or at least allows me to check if you've read it or not. The coding practice assignments are of my own creation. You may find them easy, you may find them frustrating, because really what all they're saying is, for topic 3, write a program that demonstrates something you learned in topic 3. Write a few sentences about it. Whatever you choose, be creative. If you can't think of something, don't steal it from the internet. But otherwise, just be creative. And we'll talk a lot about our Replit programming platform. We're not going to get to that in today's class. Our weekly labs and projects, that's going to be pair programming in the lab. Who here is in the Tuesday lab section? You have lab tomorrow. We'll see you at 8 a.m. tomorrow? I'm not going to be here at 8 a.m., but he will see you at 8 a.m. tomorrow, and you get to meet him, and he'll inspire you in lab on Tuesday. It'll be pair programming. You may not even be able to see the lab assignment yet, because I think it's assigned to groups in Canvas. I actually have to check that, and he will get you picked out in your groups and assigned into groups tomorrow morning. There isn't anything you have to look at first. You can look at our Replit platform if you want to see what the assignments are. These will kind of go up in difficulty as the semester goes on, culminating in a roughly 4-week-long group project that you will get to propose, you will get to work on with your partners. Yeah? I think it'd be good to have your laptop in class here today. With the big, massive caveat, it's good to have it if like you're following along, right? So I'm all for it. Wednesdays as well. The quizzes I will be providing, and there will be one on Wednesday. It's really just a technology test for us. That's using Canvas quizzes. I made almost all of them, if not all of them, just multiple choice answers. So yes, you can do it on your phone, and I guess you'll be fine. Um, but laptops would be fine for that as well. And as we're using this kind of shared, hosted, collaborative platform for programming, the idea is that you are able to follow along live with what I am doing. This will prove really useful as the semester progresses, that you can see what code I am writing live, and after the fact, I can see what code you're writing live and after the fact as well. That's why we use this platform versus just installing some IDE software on your own laptops. It does and solves a lot of the problems for us. Okay, let's meet the staff briefly. We already did a little bit. That is me. My office is right upstairs. Those are my office hours. I try to stick to those office hours. If you need more office hours, you can see if you need to find more time with me. My office hours, and my office actually has like decent air conditioning, which is very rare in the old part of Vancouver. So if you're warm, just stop on by. Dayun will introduce himself in the lab this week. He's had 285 experience, knows his stuff. His office hours are going to be in the TLA. It'll be open, and he'll just set up a little station there. You can stop by. Didn't have a photo for him, but you'll get to meet him this week. We're here to help. I truly believe that. Previous experience indicates to me that my office hours will be full, and I'm a happy guy in office hours. I'm happy helping you. You got to come prepared, like come in, like here's where I'm struggling, bring it up, show me what's wrong, let me help you get past some of the trickier bugs that you have. I am here to help. I don't know, maybe it feels intimidating coming to the first office hours. I won't yell at you by and large in office hours. I am here to help. Communication is key though. I won't know if you're struggling if you don't tell me that you're struggling. I don't know where you'll need extra help. Likewise, in class, as I mentioned, I bring up a slide, I talk about a concept, I show a program. If it doesn't make sense, do you raise your hand and say, hey, what's going on here? What was that? Explain what just happened. Just stop me. It's okay. Otherwise, the cadence won't be right for the rest of the class. If you have a question, if you have a bug, if you have an issue, you're not the only person. Just the other person hasn't spoken up yet. So speak up, ask the question, point it out, we'll back up. I will never be upset. I will never say, oh, we're going too slow in this class, ever. So, but you need to be the one who kind of, is willing to go out there and like raise your hand or come to office hours and let me know. Canvas is pretty important, and I do want you to check it reasonably periodically. It's static in the sense that it's all set up for the semester. In the student view, you may not see all the content yet, but it's all actually there. Kind of treat it as an old school web page, but that's where all like the syllabus answers are going to be found in Canvas. It's really just one page, which has links to this top page, all the syllabus items, and we will talk more about the syllabus on Wednesday. We're not going to be able to get to all of it today. Also important would be one way to access all of the content in the course would be via that schedule page. And I'm allowed to tweak this if we fall behind or go too fast, but by and large, this will be our weekly schedule in terms of content, in terms of when you're going to have assignments, and you are going to find that there's a decent amount of stuff you have to stay on top of in this class. Every week, we're going to have a learning module. This is our introductory learning module. Congratulations, you're 1/3 of the way through it. There's going to be in-class lecture. There's going to be a quiz on Wednesday. It's really just testing that you have been showing up. There's going to be a reading assignment in that zyBooks online textbook platform. There's going to be a coding practice, which again, write and submit a program that does something related to the topic we're learning. And there's going to be a lab associated with it. Some of the labs will span a couple of weeks because they're a little bit more challenging than others, but by and large, you can think of this class as having a weekly lab that you are expected to attend. This schedule is a good thing to check. It shouldn't change by and large. Maybe I'll move a topic by a day or something, but by and large, it should be pretty static here to kind of see where we are this semester, what you have coming next. And while it's just kind of the student view here, you will start to see all the things that will eventually be due this semester. It is a decent number of things to keep on top of each week. Don't let yourself fall behind. I kind of want to keep us on that steady cadence in terms of submitting things on time, getting credit for the work that you've done on time, being fair to all your fellow students with regards to keeping up with the rest of the class. Let's leave things here for today. I'll see some of you tomorrow morning, the rest of you on Wednesday, and good luck. Let's have a great semester.